This is a question about haloalkanes. It is a 10 marker, 3 sections, A, B and C. Here's A, part B and part C. Okay, so within this mechanism for part A, we know we're making the alcohol and we've been given some conditions that are going to guide us towards which mechanism, because obviously there are two to choose from on this one where OH minus is added to a haloalkane. I've written my OH minus out. I'm ignoring the sodium. That's merely a spectator. And the OH minus is going to attack the carbon. The OH minus is electron rich. It's attacking the delta positive and therefore electron deficient carbon. And the curly arrow always represents the movement of electrons from electron rich to electron deficient. Now, because that's essentially creating a bond with the carbon, 5 bonds around the carbon is not sustainable, so the Br goes. Now, in terms of naming the mechanism, the OH minus has a lone pair that it can donate. Therefore, it's acting as a nucleophile, so the mechanism is nucleophilic. And the OH minus is essentially replacing the Br. So we're substituting. It's nucleophilic substitution. In terms of the calculation, we are working out percentage yield. Now, there's a lot to think about here. We want to know, to start with, the moles of our haloalkane. Unfortunately, we don't have an M and an MR or a C and a V. So we need to find another way around it. What you do notice is that we've got a volume and a density. So we can work out the mass in that way. Mass is density times volume. 2.52 grams of the 1-bromo 2-methyl propane. Now from there, I can put that figure in with the MR value provided and I get 0.0184 moles. Now, if that's how many moles of the haloalkane I've started with, that's how many moles of the alcohol I would expect to end up with. And I've been given the MR for it, so I would expect a mass of 1.36 grams. I didn't get 1.36 grams, I got 895 milligrams, which I've converted to 0.895. Now, if I take the 0.895, which I got, and divide by the 1.36, which I should get, multiply that by 100, I get my percentage yield of 65.7%. Finally, on to part C. I'm going to do the mechanism in the space so we can see the alternative. Note that this is concentrated ethanolic hydroxide, so that's the condition that they're in. Now, actually, earlier in the question, when the conditions spoke of aqueous, that should really now say aqueous ethanolic. It's just that this is an older question. The difference is it aqueous ethanolic or is it concentrated ethanolic? Now, concentrated ethanolic, the OH minus is going to act as a base, so it's going to attack the hydrogen. That takes the hydrogen away, so the electrons from the CH bond move in to form a double bond, and we therefore lose the bromine, and we end up with this product. Now, the name of that product is methylpropene, and the mechanism, because we have lost things from it, we've not replaced, we've not added anything new, this is elimination. As a general rule, if you end up with a double bond that wasn't there before, it's an elimination mechanism.